Alright, tonight we're going to start working with central angles and inscribed quadrilaterals. So the first part is a central angle, and we need to go back to our definition which we worked on today in class. A central angle of a circle is an angle whose vertex, which is the corner, is the center of the circle. So if you notice, here's our angle, angle ACB. And this vertex of the angle is C, which is also the center. So we wanted to find out the measure of our central angle. We would take our protractor and make sure you put the little arrow right there at your center. And then you want to make sure that one side matches up with the 0 on your protractor. And your other side of your angle, you find the degrees, so the angle would be 60 degrees. And notice the arc is also there, so the arc would also be 60 degrees. So your central angles are going to be equal to the arc that it intercepts. Again, our centers here match up 0 on one side of your angle, and the other side matches with the number. Central angles equal the arc. So what they're wanting us to do is they're wanting us to be able to find the measure of arc ED, and this is your arc symbol. So if I look and see, I'm going to start with E, and I'm going to go the shortest route to D. Arc ED is intercepted by the central angle EFD. So the measure of arc ED would be 52 degrees because the central angle is equal to its intercepted arc, 52. On this one, it wants us to find the measure. The M stands for measure of arc. Here's your arc symbol, EA. So if I go from E to A, I go the shortest route from E to A. So that would be there, and EA is intercepted by angle EFA. So the measure of arc EA would be 97.4 because that is the measure of the central angle that intercepts arc EA. If I want to find the measure of arc, there's your arc symbol, DA, I'm going to go to the shortest route from D to A, so I'm going to go counterclockwise. Now notice I have two angles together here that form that arc. So what I have to do is I have to add those together. So I get my calculator and I find out what 97.4 plus 52 equals. And my answer is 149.4. So the measure of arc DA is 149.4. On this one, they want us to find the measure. M stands for measure of arc. There's your arc symbol, BC. So the shortest route from B to C is here. It's formed by angle BFC, which is a central angle. Now, I need to find that, but I don't have a number there. Notice that this angle and this angle, EA or EFA, are vertical angles because they've two intersecting lines, so therefore they're equal. So arc BC would also equal 97.4. This question wants us to find the measure of arc EAB. So I go from E to A to B. Now what I notice here is this is on your diameter. And my diameter splits my circle in half. So I know that's half a circle. So that would be half of 180 or half of 360, which is 180 degrees. Semicircles are 180 degrees. On this question, it wants you to find M stands for measure of arc AB. So I go the shortest route from A to B. That's formed by angle AFB. All right. There's not a number there. It doesn't have a vertical angle. So what I need to do is I know from the last problem that this right here was my semicircle. So I'm going to say to find AB, I know the semicircle has 180 degrees, and I'm going to subtract the 97.4 because I already know that part of my semicircle. So in my calculator, I would say 180 subtract 97.4, and that would tell me arc AB is 82.6. This question wants us to find the measure of arc, there's your arc symbol, DC. So I want to go from D to C. Well, I know from the last question that's formed AFC. I know from the last question that this arc, there's your vertical angles. I know this one was 82.6. So if I want to find the other part, I've got this part, this angle right here, which is a vertical angle. It's got half of it's 52, and I need to find the other part. So to find it, I'm going to say 82.6 subtract 52 to get the rest of the arc. And that's going to tell me my answer is 30.6. So arc DC would measure 30.6. Alright, the other part of tonight's lesson was inscribed quadrilaterals. Remember, inscribed means inside the circle. A quadrilateral is a four-sided shape. And the theorem tells us if a quadrilateral is inscribed in the circle, then its opposite angles are supplementary. Now notice, here's my four-sided shape. It's definitely inscribed. It's inside the circle. So I know the opposite angles. Well, we talked about opposite angles being across. So I know that A and C are going to be opposite angles. I know that D and B are going to be opposite angles because they're across from each other. So the conclusion is that A and C are supplementary and B and D are supplementary. So the question now is, what is supplementary? Supplementary means two angles that add to equal 180 degrees. Remember how many times I said complementary? You need to remember supplementary now. It's an important word. So if I want to find the measure of angle C, which will be located here, I've got to take the theorem that says opposite angles in an inscribed quadrilateral are supplementary. So I know that these two angles add to equal 180. So I know that 110 plus measure of angle C equals 180. So the easiest way to find angle C would be to subtract 110 from both sides. So the measure of angle C has to be 70 degrees. In this question, I want to find the measure of angle B. So I locate angle B. Here would be angle B. I notice it's in a quadrilateral because there's four sides. It's inscribed in a circle. And I remember the theorem says that opposite angles in an inscribed quadrilateral are supplementary. So that means that if I add angle D, which is 75 degrees, to angle B, which we don't know, they have to equal 180 degrees because supplementary means they equal 180 degrees. So to solve it, I need to subtract 75 from both sides. So that tells me the measure of angle B must be 105 degrees. Now here's a little tricky one. If I want to find the measure of angle A, I notice it's inscribed, angle A is in a quadrilateral, this inscribed in a circle. So I go back to my theorem that says opposite angles in an inscribed quadrilateral are supplementary. So I know angle A plus angle C, which we'll use X, equals 180. So to solve for angle A, I need to subtract X from both sides. Now the problem here is I can't subtract 180 and X. So I just simply write down angle A is 180 subtract X. Now this question also wants me to find angle D. Well, I notice angle D is across or opposite from angle B. I know that they're also supplementary. So I know angle D plus angle B, which is represented by Y, equals 180 because they're supplementary. So to find angle D, I need to subtract Y from both sides. But again, I can't subtract 180Y. So angle D has to be 180 minus whatever Y is.